feast your eyes upon this wonder of homebrew engineering. It's a heap of firewood shaped like a lathe with a few bits of metal. I almost didn't take her home last Saturday, a bit too old and too ugly for my taste. But now I'm glad I did, because I think I can have some fun with her here in the Temple of Tools. Let's check her out from head to tail. Stock. The headstock is made of what looks like a homemade spindle and two big SKF flange bearings and a nice pulley, aluminium, probably also homemade. The bearings are bolted to a thick metal plate, and that is bolted to some firewood. These are probably plain bearings, but I find it a bit strange that there is no loop point on here. There's a dry spur, and I'm hoping this can be removed so that I can make a faceplate for it, which I need if I want to turn a big bowl, which is basically the plan for this thing. Center height for this beauty is a bit over 30 centimeters, and that is about 12 inches. So in theory you could do a 24-inch bowl on this thing, which is respectable. Here's a tool rest, a highly precision piece of engineering made in a time when Napoleon ruled over Europe. It's clamped down with a piece of wood, and it has one of those annoying big handles to tighten things up. But it should probably work fine. Here's the motor that came with the lathe. There's no mounting bracket on the lathe. The previous owner had it bolted to the wall. It's probably, well, it's configured to run single phase, and it probably is a single phase motor. There's no information plate on it anywhere. I've checked. The one thing odd about it is that it has a shaft on the rear end. It has the same pulley as the headstocks, so there won't be much belt length difference between the three speed settings. Yeah, that's what I thought. Steel. So this thing is probably from the late 50s, maybe early 60s. It also came with a bunch of chisels, some gouges, all pretty much worn out. They look to be converted woodworking chisels, just add longer handles, a couple of files, and this thing. I don't see how you would use this thing on a wood lathe. The frame is made up from reused wood and not very stable. The previous owner had it bolted to the wall, so that made a huge difference. These are 10 by 10, and this leg is 17 by 12 centimeters. This seems to be held together with only one bolt, although it is, well, how do you call it, integrated into the headstock post, the headstock pillar. No idea what to call it. No cross bracing whatsoever. Pretty flexible, pretty flexible. And so we come to the tailstock, which is made mostly from metal and some wood. These blocks here, they almost look like they were added later to raise the height. Yeah. Not very smooth sliding. It could use some oil. There's a piece of all thread running to the whole length of the tailstock, and on this side they used a well, this handle with also a thread on it to lock it, which resulted in most of the thread being eaten away. So now there's quite a bit of play here. We call that not good. It does, however, have a life center, which is surprisingly smooth. We call that good. So here's my plan for this marvel of human ingenuity. I'm gonna make a motor mount, then I'll wire up some electrics, switch and some cables. Then I'll put some cross bracing, reinforce the frame a bit. Maybe I'll put it on casters so I can use it outside. And then I'm gonna test it. And if it's any good, I'll play with it in the summer. If she turns out to be a total waste of time, which she probably is when you look at it, then I'll scrap it and save a few bits for a lathe build of my own. I'll try to fix it this week, and I'll come back with another video where you'll be able to see this thing running. Well, hopefully running. In my last video I showed you this homemade wooden wood lathe made from some firewood. At the time it needed a motor mount, and now it has one, so we can do some testing. I cobbled together this basic construction that is pretty self-explanatory. Or do I need to explain it for the 5% women folk that according to Google is watching my channel? This wooden box-like construction here pivots around this bolt, and that allows the motor to move up and down a bit, so you can change the belt to a higher speed setting on the pulley. This here is a pulley, in case you didn't know that. If needed, the bolt here can be tightened to stabilize the motor. Got it? Okay then, moving on. Now we are going to find out if my creation is actually working as expected. This will be the first time I'm going to start it. Maybe the motor will rip it apart. Knowing who made it, it is not impossible. I think it's in the off position, but I'm not 100% sure. So it might start when I plug it in. Okay, that's good. Here we go. Nice! Not bad at all. That was a lot better than I expected. I'm gonna take out the drive center so I can drive my speed tester. With this pointy bit, it's not gonna work. About 1500 RPM. So, assuming that the pulleys are of equal size, the motor is also a 1500 RPM unit. Let's test the other settings. Almost 1000 RPM for the lowest speed. That's a bit much if you want to turn a big ball. Alright, here comes top gear. A bit over 2200 RPM. Before I do a little test turning, I want to see what's in these bearings. Maybe they need a little oil, I don't know. Oh, look at that. That's normal ball bearing. There are 2 rows of ball bearings. It's coated in a very thin, well, a thick oil of very thin grease. I wonder if I should add some bearing grease. Although I read somewhere that lots of bearing get damaged by adding grease. Probably too much grease. I wonder if these things can take a thrust load when you push in on the spindle nose. I will write down the numbers and look them up on the internet. Alright, I'll skip the grease for now. A bolt escaped and close them up. There's a piece of felt here to keep dirt out. Let's mount a piece of wood and do a little testing. Adjusting the medieval tool rest. Annoying old piece of crap. This is a piece of what we call American oak. Don't ask me for the Latin name. It's about as stable as a ocean liner in a hurricane, but we're gonna try it anyway. I've got the lathe at the lowest speed setting, that's 1000 RPM, and I'm hiding here behind the headstock, hoping that when I flip the switch this thing won't come off flying into low Earth orbit. Here we go. Well, at least it stayed in place, but it is a bit shaky. To be honest, I'm a bit afraid to take a cut. It's spinning way too fast for me. Maybe I should do a test. Well, that seems to be pretty fixed in there. Well, let's take a cut. And I'm wearing my lucky safety squint, so nothing can happen. Well. Those chips are coming right at me. Man, those chips, they fly a lot further at 1000 RPM. And they were hitting me straight in the face. The lousy stability isn't a big problem. I didn't really notice it that much. I must say that it's running way too quick for my taste. I guess I should also test one of those worn out gouges that came with the lathe. Man. This thing is digging in. Takes real big chunks off. Also a bit loose in there. Yeah, not the best tool. Rejected. One more test from another angle. Well, that's enough. Okay, one more. I guess it isn't a proper test till I used my homemade gouge. Well, you gotta have one catch at least. Well, that concludes testing. For now I'm gonna put this machine away, see if I can find a 3-phase motor and a VFD drive for it. And then when I have a proper ball gouge and a big ball blank, I'll drag it outside and have some fun with it this summer. For now, I'm done. Till next time.